Hello to everyone, my name is Giuseppe Melfi, I'm a researcher at Karlsruhe Institute of Technology and I will present our work on TPad, a mobile audio-tactile system for graphic use at school with students with visual impairment. Nowadays, a lot of information is presented graphically in educational environment. We have, for example, histogram, flowcharts, scatterplot, maps, and so on. But students with blindness don't have access to this visual information. The topic of our work is how to make graphic accessible to blind students. A possible solution is to provide an alternative text, a textual description of the graphic that will be accessible for the student using a screen reader. This is the only method that currently have for complex graphic, but it has also some limits. In particular, the descriptions are produced manually by experts that try to don't introduce an interpretation of the graphic, and the most important problem is that exploring graphic to discover information independently is a fundamental part of the learning process. A second solution, currently in use, is to provide to the student a tactile graphic, an image with raised surface that can be felt with the fingertips. A problem that comes with this solution are the extra lines and labels that make the tactile graphic complex to read. The second issue is the space for including text in Braille, that is extremely limited. This means that some information is put into a legend, a key, and the tactile graphic required oft also a global caption for a general overview on the graphic. This means that this solution is affected by a fragmentation of the information problem. To solve the problem of the previous method, we proposed TPad, a mobile audio-tactile system for graphic use at school. It is composed by 4 parts: a standard tablet, in our experiment an iPad Pro, a frame printed with a 3D printer to easy fix the tactile graphic on the tablet, a mobile application that was developed as cross-platform app, and a Raspberry Pi that works as a server. On the server we have also a repository with all the audio-tactile files, a converter. The system is compatible with standard SVG file, but thanks to the converter, the teacher can also load into the repository file other formats, for example draw open document, and a backend with some feature for the teacher. Last, the server can also provide an hotspot for local network, useful in case an internet access to the is not available in the classroom. To explain how the system works, I will show you a short video. To use TPad, the first step is to fix the frame on the tablet and to open the TPad app.
Scan QR code.
Then we load the audio-tactile graphic using the QR code. Each tactile element provided with audio description is highlighted with a short tone by the system. With a double tap, we get the description using the speech-to-text technology. Using the backend, a remote control is also available. The teacher can load the desired tactile graphic on all the connected devices during the lesson. In our study, we compared 3 different methods to explore a tactile graphic. In the first 2 methods, the most important graphic elements are labeled in Braille and the actual information of the graphic is provided in a legend, printed in Braille for the first method, and saved in a Word file for the second method. The last method is our TPad system. The test was conducted with 5 blind students, thanks to the collaboration of the Tilly Liechtenstein School of Nicholas Pflege in Stuttgart. The study hypotheses were the audio-tactile graphic TPad method has higher efficiency, effectiveness, and satisfaction than the other methods. The second was the student memorized more information after having explored a tactile graphic using TPad than with the traditional method, as the learning process is not interrupted by the consultation of the key index. The design of the test material was done in collaboration with two teachers of the school and using real educational material. On the slide we can see one of the graphics used during the test. On the left side there is the original version of the graphic. In the middle we have the tactile graphic preview, where you can see the Braille labels. On the right we have the version compatible with TPad that doesn't require Braille labels. The user study was divided in two experiments. In the first experiment, the participant received a tactile graphic and could explore it autonomously without time limit, but we asked the participant to be as quick and accurate as possible, and exploration time was recorded. After to have explored the graphic, the participant received two questions. To answer this question, he could consult the tactile graphic. A third question was given to the participant. This was a memory question because he could not use the graphic to answer this last question. The procedure was repeated 3 times, one for each method, using 3 different tactile graphics. Considering the average exploration time, the TPad system has recorded a better performance, with a statistically significant difference with both the other two methods. Considering overall the correct answer of all the participants, the two methods, TPad and Braille key methods, are similar and both with good effectiveness, more than 70% of the correct answer. The digital key methods instead did not reach satisfactory levels. It is interesting to note that 4 out of 5 participants answered the last question correctly, based only on their memory without to have the possibility to consult the graphic. The 3 methods have a similar value for the NASA TLX index and for the system usability scale. All the participants were in favor of the TPad system, except one that expressed 2 options, the TPad and the Braille key method. 3 students preferred TPad because they considered this system faster. One reported that he hated to read Braille, and with TPad this is not necessary. Another participant reported that he likes that all the information was in just one place. There are 4 different ways to load an audio-tactile graphic into the TPad system: loading a local SVG file, using the teacher's backend through the remote control, by navigating the menu with the list of the graphic in the repository, and scanning the QR code on the back of the tactile graphic. The second experiment was focused only on TPad, and in particular we compared the last 2 methods to load an audio-tactile graphic. The QR code method was an unexpected fast strategy. One participant was able to load the graphic in less than 2 seconds, and all the participants expressed their preference for the QR code method. Access to visual content using tactile graphic is essential for students with visual impairment at school. With our study, we showed that audio-tactile graphics are an effective teaching tool for blind students. Using TPad, the participant acquired the knowledge about the tactile graphic faster than with the other 2 methods. In our experiment, they answered correctly more than 70% of the question, and the possibility to focus on a single device is likely to affect positively the memory process. Thank you for your time. If you have any question, please contact me at giuseppe.melfi@kit.edu.